Architecting agents made simple yet powerful. Without wasting your time, in less than a minute, I'll quickly show you how to build an all-purpose AI agent. And then I'll give you a working demo in the next 2 minutes. Then I'll briefly explain what an agent is and how clean architecture made it simple. Next, in the second half of the video, we will explore some important architectural concepts, including distributed agents, MCP, agents with microservices, performance, scalability and maintainability, and autonomous agents. I'll keep everything simple and logical so that you can actually understand them. Now let's quickly build the all-purpose AI agent. This is the existing code. And these are all the use cases that already exist in our personal assistant app. We have use cases for tasks, commitments, and scheduled items. Now I want to create an AI agent that can perform all of these existing operations through an AI-driven flow. I'll create an agent, provide it with a model to make it intelligent, create tools for each use case, and provide all those tools to the agent, like this. Now let's run the code and see how it works. Let's see some basic stuff that this all-purpose agent can do. Show me all the tasks. Change the priority of the task related to calling my friend to the highest priority available in the system. Notice how I'm simply talking to it in plain English. It says it's done. Let's verify. Show me full details of all the high priority tasks. Yes, the priority has been set. Can you create a new task? Yes or no? Yes. Create a task to renew my driving license due on October 5, 2026. Done. Great. Show me all my commitments. As per the agent, I have 7 commitments. Let's verify that these data matches the database. Send book to friend, plan a birthday party. Send book to friend, plan a birthday party. Perfect. Create a commitment to buy a toy for my son. Done. Let's verify it's actually stored in the database. Yes. Yes, it's there. Our agent is working. See how simple that was. In just a few minutes, we built an all-purpose AI agent. Everything in the system that users could previously do through the UI can now also be done simply by talking to the agent. And this is just the simple stuff. Later in this video, I will show you this same agent doing far more complex work. So stay with me. Now, before we get into the architecture discussion, let me quickly explain how it all works. First, what exactly is an agent? An agent has a model, memory, and tools. The model, or LLM, is the agent's brain. It uses the model to reason about things. That's what makes it intelligent. The memory helps it remember user preferences and other important details over the long term. And tools are the agent's hands. It performs operations using tools. This means it can not only describe ideas, but also execute them. The good thing about agent is that we don't have to dictate every step. Instead, agents are smart. We assign them all the necessary tools they need to do their job, just like we have done here. And then they decide for themselves when they need to use those tools as per the need. See this. Find the task related to license renewal, set its priority to the highest, change its status to in progress, and then share its details. This requires the agent to perform multiple operations using the right set of tools. Find the correct task, update the priority, change the status, and then retrieve the details. The agent already has all of these capabilities at its disposal. When I run it, as you can see, the agent automatically calls the right tools and uses them to complete the request. That's how an agent works. But how did we build it so quickly? In our case, one major reason is that we are using clean architecture. If you don't fully understand clean architecture, I have a full video on it. But in short, it keeps the business logic highly decoupled and pluggable, which means you can plug in any database or any other adapter at any time without changing the business logic or anything else. And similarly, you can plug in any user interface and start consuming the same application from a different client. And that's the key idea we use to build our AI agent. We simply plugged it in into a new interface, the AI agent. All our functionality was already pluggable because of clean architecture. We simply started using it as is inside the agent. Of course, we only had 10 or 12 use cases. In a real production application, there can be hundreds of use cases. And of course, it will take a little more than that to make it production ready. And not everything will work automatically all the time. You may need a multi-agent system. You may need to make few adjustments depending on your own needs. For example, right now the agent is filtering the records in memory. We need to fix this. Let's first see what the agent can do and then discuss this concern. As you can see, I can filter records. I can even give it a very advanced filter. You can get the count, find the maximum or minimum. We can do group by, do sorting, or perform any other complex query. It works, but in a production scale application, we cannot fetch all records in memory before applying the filters. Instead, we need to make sure the filtering is applied at the data source level while still keeping semantic search enabled. How can we do this? Share your thoughts in the comments or let me know if you would like a separate video on this topic. Now that you are familiar with AI agents and clean architecture, let's quickly touch on a few architectural considerations. Question: what if we need to make a distributed agent? Suppose the business logic runs on one server and the AI agents run on different servers. Now the question is, how do we expose the use cases from one server to agents running on different servers? The answer is MCP. We can use an MCP server to expose those use cases. And agents running on different servers can use them using an MCP client. Previously, both the agent and the use cases were running on the same server, so we didn't need MCP. We simply used direct method calls. But with distributed agents, we need MCP. It provides a standard way to expose tools to agents running in other applications, on other machines, or even in different companies. This means the agents no longer need to run on the same machine. This gives us much more flexibility when designing scalable and resilient systems. And it also gives our agent the ability to integrate with third-party systems. Now, what if we have microservices architecture and each service implements a particular subdomain? We can add an MCP server to each microservice, expose its use cases as tools, and agents can use them from other machines. Let's quickly see that in action. I have 3 microservices. On each service, I'll create tools for each use case. Add this attribute and create an MCP server like this. Now all these tools are ready to use for other services. I'll do the same on all 3 services. Next, on the agent side, I'll connect to those MCP servers using an MCP client and provide those MCP tools to the agent. That's it. Now let's run the code and use it. I'm talking to the agent now and it's working. And as you can see in the logs, these methods are being called, which means the agent is actually using all those tools running across different microservices. We can even add a breakpoint to confirm that the methods are actually being called inside the microservices. And there it is. It's working. Now let's talk about performance and scalability. But before that, let me give you a quick demo. Create 100 dummy tasks and show all of them. Done. Agents are powerful, but that power also introduces a whole new set of architectural challenges for developers and architects. What if I say create 1 million dummy tasks and show all of them? Think of someone from quality assurance setting up a new testing environment, or someone evaluating your product and preparing a demo. And think of autonomous agents. They can work independently and integrate with many other systems. The amount of load these agents can put on your system can be significantly higher than the load generated by a human. What does that mean? This means the scalability requirements are about to change completely. The scale we design for today may no longer be enough. We will need much more than that. And that's why I think learning software architecture will become more and more important in the coming years. And not just scalability, performance, maintainability, fault tolerance, all these architectural qualities will become more and more important. Tell me in the comments whether you agree or not. Anyway, what can we do to handle this particular scenario? Maybe we can use batching. Instead of performing individual actions, we can design agents to work in batches so they can be more performant and scalable. What we will do is implement methods that work in batches and expose those methods to the agent as tools. I would encourage you to try this. Next, how can we keep our code maintainable? First, in our clean architecture approach, we had separate layers for business and agents, which means our AI code and business logic don't get mixed up together, making them maintainable. And the same is true for distributed agents because the business and agents live on different services. This is already clean and maintainable. On top of that, another high maintainability thing that we can do is to keep a common framework abstraction for agents. It contains all the base functionality and generic code related to agents. Think about long term memory, context engineering, RAG, or API level streaming support. We can keep all of these core capabilities at the framework level, which means that as we add new agents, we don't have to implement all this base functionality again and again. We get it out of the box. Check out my videos on abstraction if you would like to learn more about this. But just to give you an idea, suppose you need to add audio chat support for a particular agent and you decide to implement it at the framework level. What does that mean? It means that once it's implemented, audio chat support becomes available to all agents out of the box. Every new agent that you or anyone else in your company creates will have this capability built in. And later, when you update something, those improvements become available across the system. This is particularly useful in AI, where the landscape is continuously evolving. Now, before I end this video, let's discuss autonomous agents. So far, our agent has been responding to user requests, but it can also work autonomously in the background, doing work while we are sleeping. How can we do this? We can do it like this. Let's see what we are doing here. The business raises a task created event. In a monolith, this could be in memory, and in a distributed system, it could be a messaging event. The agent service subscribes to that event, task created. When it receives it, it creates a prompt like this. A new task has been created. See if you can do it. If yes, do it and mark it as done. If not, assign it to me and write the findings in the comments. This makes the agent to work autonomously when a new task is created. And if you think about it, it's actually quite straightforward. Let's see. The agent is already capable of doing all the work, right? To the agent, it doesn't matter whether the prompt comes from the UI or from a background event. In fact, it doesn't even know who is calling it. So, to make an autonomous agent, we just need few simple steps. We need to publish events from code. Listen to those events, create prompt, and pass it to the agent, and the agent will do the rest. We can have scheduled jobs that trigger agents. We can have more business events or events triggered by external systems, and so on. That's how we build autonomous agents that can work independently without anyone actually sitting behind a desk. And of course, they can take human in loop whenever needed. Do you think an FSM can be helpful in building autonomous agents? Finally, this video was less about the architecture inside agents and more about the architecture around agents. I hope you found it useful. Agent and multi-agent systems are still new and continuously evolving. In this video, I have shared some high-level architectural opinions based on my current understanding at the time of creating this video. Tell me in the comments if you know better or alternate approaches. Tell me how you are architecting agents in your systems. I would love to hear your thoughts. Check out my channel for more videos on software architecture.